All right, it's recording now. Okay, perfect. All right, so I mean, in general, guys, probability, it's just, it's a number. It's a numerical value. It's a number between 0 and 1, okay? And it actually describes the likelihood that an event will occur, okay? So probability is just a number. It's a numerical value, is a numerical value right? Between, so this number, it's between 0 and 1. Okay. And so this number actually describes the likelihood that an event will occur. Okay. So what I mean by event will occur, I mean an event will happen or will take a place, right? So it's just a number between 0 and 1. And if you are very close to 1, okay, then it means there is a great chance of occurring. So closer to 1, then there is a great chance. There's a great chance that the event will occur. Okay. And if you are close to 0, then there is a very low chance that the event will occur. So this is a low chance that the event will occur. So when I say, guys, 1, between 0 and 1, you know, 1 means actually 100%. So when I say, for example, so when I say 1, this is like 100 over 100, and that's 100%. Okay. So keep in mind the percent symbol means division by 100. So this symbol here, this percent means division by 100. So of course, 100 divided by 100, it's 1. So division by 100. Okay. So when I say 0, I mean 0%. So there is 0 chance that the event will occur. So 0, this is like 0 over 100, and that's like 0%. Okay. Now, if you take a decimal between 0 and 1, for example, if you say 0.54, that will be like 54%. Okay, so if you have 0.2, actually you need 2 decimals after the dot. So 0.2, this is like 0.20, and 0.20, that's 20%. Okay. Of course, if you have like 3 digits after the dot, for example, if you have like 0.0675, so that will be 67.5%. Okay. So you always take like 2 digits after the dot, right? So 2 digits here, 2 digits here, that's 20%. In here, you take 2 digits after the dot, so that's 67.5%. Okay. So yeah, so a number, so if you have like a number between 0 and 1, that will represent like a sort of percentage, and that will be your probability, right? Now, so yeah, I'm gonna introduce some notation first before the examples. So we denote notation. So probability of an event A by P of A. So when I say P of A, this is the probability of the event A. So this is probability of an event A. Okay, so the P stands for probability, right? And A, that's our event. Okay. So for example, if you say, so for example, if you say P of A is 100%, okay? So P of A 100%, it means that the event A will occur, right? 100%, so we are sure that the event A will occur. So 100% means that, so this means that the event A will occur. The event A will occur. Okay. Etc. All right. So now the question is, how do we compute the probability of an event A, right? So question. So how do we compute the probability of an event A? Okay. So actually, in general, we have like two different formulas to compute the probability of an event A. The first formula is based on the frequency of the event. Okay. Remember, like for when we make the frequency table, the frequency, to find the frequency, you count how many data values are between your classes boundaries or your classes limits, right? So the same thing here. To compute the probability, you need to find the frequency of the event. So so the first formula, so formula one, this is the most common formula. We're gonna use this a lot. Formula one. So the probability of the event A is actually equal to the frequency of the event occurrence. So how many times the event occurred. So frequency of the event occurrence. Okay. Over the total size of the sample. The size of the sample. So again, guys, by the frequency of the event occurrence, I mean how many times does the event occur, right? So here, frequency. So what do I mean by frequency? I mean how many times does the event A occur? Okay. And so then we divide the frequency over the size of the sample, right? So in other words, this is like you know, when you divide frequency by the size of the sample, this is like the relative frequency, right? So actually this probability of A, it's just the relative frequency. So this is, so P of A. So in other words, this probability of the event A, this is like the relative frequency. You divide the frequency by the size of the sample. Okay. So that's what I call, so this relative frequency is actually the probability of the event A. All right, so let's have a couple of examples. So let me give you one example and then I will give you a couple of exercises to practice. So here's an example. So let's say we have a sample of 500 students. And so this is a random sample. Of 500 students. So 500 students, they were surveyed, okay? And it was determined that, surveyed, and we know, or it was determined right, that, so out of the 500, we have 375 students, they wear glasses. Okay, so let's say you want to find, so find the probability that so find the probability that a random student is, you know, a random student wears glasses. Okay. So we have this sample of 500 students, right? So the size of our sample is 500 because we have 500 students, okay? And now we are looking for the probability that a student wears glasses, right? So the event here, so the probability that the student, a random student, wears glasses, right? So we are looking for the probability of the event where the student is wearing glasses, right? So our event A here, so the event A, so the event A is that the student wears glasses. That's our event A. And we are looking for the probability of this event A, that the student wears glasses, right? So we are looking for P of A. Probability that the student wears glasses. All right, so if we're gonna use the formula, so the formula says the frequency of the event occurrence over the size of the sample. So what's the frequency of the event occurrence here? So how many times, again, what I mean by frequency of the event occurrence is how many times that the event occur, right? So out of this 500, so how many times or how many students are wearing glasses?
375.
375, right? So that's the frequency of our event. The 375, thank you.
So it's gonna be
So,
275 over 500.
over 500, absolutely. The 500, that's the size of the sample. So absolutely. So this is the size of the sample because we have 500 students. This is the size of the sample. And this is the frequency. So how many times a student is wearing glasses? Well, there are 375 students wearing glasses. So this is the frequency of the event. Okay. And now you need to divide, guys. So you can use your calculator. 375 by 100 by 500. That will be equal to 0.75. So this is 500. That will be equal to 0.75, and that's 75%. So what we are saying here is that there is a 75% chance that the student is wearing glasses, right? That's, so of course, this is our answer. This is the answer right here, okay? And so what we are saying, the conclusion here, what we are saying is that there is a 75% chance that a student is wearing glasses. Okay. Well, before the exercises, guys, let me just say one more word here. Let's say you are looking for, so this is like the first question, second question. So number 2, let me just, so this is question 1. Find the probability that a random student wears glasses. All right, so second question, or question number 2. Find the probability that a student is not, find the probability that that a student is not wearing glasses. Okay. Is not wearing glasses. All right, so again, we have the same sample. We have 500 students. Out of the 500, 375 are wearing glasses, right? Now, so now we are looking for the probability that the student is not wearing glasses, right? So how many students, what's the frequency of the event here? How many students are not wearing glasses?
25.
Out of 100, so that'll be 125, you mean, right?
Okay.
So we have, because we have 500, so that's 125, right?
Oh yeah.
Mm-hmm. So the frequency here of this event, so of the event B. So here B, the event B is, so B is, let's say, this is the event where a student is not wearing glasses. Okay, so yeah, as you said, Janabu, so the frequency of this event B, so then the frequency of B, so that would be the size of the sample. We have 500 students. out of the 500, we know that there are 375 students wearing glasses. So 500 minus 375, so that would be 125. Okay, so we know there are 125 students not wearing glasses, right? Now, so then the probability of the event B. So probability of the event B, that will be the frequency of the event B over the size of the sample. And so 125 over 500. Okay, so that will be equal to 0. So this is 0.25. And in other words, this is 25%. So there is 25% chance that a student is not wearing glasses. Okay. So there is 25% chance that a student is not wearing glasses. All right, guys, so before the exercise, let me just say, just one remark here. You know, a student, so if you take a student, right, then a student is either wearing glasses or he's not wearing glasses, right? So, and as you can see, here, the probability of the event A, that the student is wearing glasses, is 75%, right? We got 75% chance that a student is wearing glasses, and 25% chance that a student is not wearing glasses, right? So, you know, 75% plus 25%, that's 100%. And 100% is equal to 1, right? So, so this event B, that the student is not wearing glasses, this is like, this is the event that the event A is not, does not occur, that a student is not wearing glasses, right? So the event B, so there is a relation between the event A and the event B here, right? So the event B, so the event B, again, the event B is that a student is not wearing glasses, right? So that's the event, is the event that A, the event A was that the student is wearing glasses, right? That A does not occur. Because again, B is the event B. This is when a student is not wearing glasses, right? Not wearing glasses. And A, that's the event where the student is wearing glasses. Right? So actually we say that this event B is the complement of the event A, okay? Because again, if you take a student is either wearing glasses or not wearing glasses, right? So B is not wearing glasses, right? And A is wearing glasses. So the B is just, we say that B is the complement of A, right? Because either A or B occur, right? Either the student is wearing glasses or the student is not wearing glasses, okay? So the event B is called the complement of the event A. So this event B is called the complement of the event A. Okay. Because the event B is the event where A does not occur, right? So that's the complement. And actually, there's a notation for the complement of the event A. Actually, we denote the complement of A by A. So this event B, this complement. So the B is actually denoted by AC. So this AC means, so this notation right here, this is the complement of A. And again, complement of A means that A does not occur, okay? So of course, either A occurs or A does not occur, right? So then the probability of A, so in general, probability of A plus so as I said, like in our example, the probability that a student is wearing glasses is 75%. The probability that the student is not wearing glasses is 25%. So 75% plus 25%, that's 100%. And 100%, that's 100 over 100, and that'll be equal to 1. So in general, the probability of the event A plus the probability of the complement of the event A is always, their sum is always equal to 100%. Okay, so the probability of A plus the probability of the complement of A, okay, this is always equal to 1 or 100%. Okay, and again, as I said, complement of A means that A, so here means that A does not occur. Okay, and this probability of A, this is when A does occur. Okay. Any question, guys, before the exercises? So anyway, so what we need to keep in mind, guys, to compute the probability, one way to compute the probability of an event A is to use this relative frequency, right? Which is the frequency of the event over the total size of the sample. So that's how we compute the probability of an event A in general, right? So here's the formula again, right? This is our formula we're gonna use in the next exercises, right? So probability of A, that's the frequency over the size of the sample, right? In other words, that's the relative frequency. All right, so here's an exercise for you guys. So exercise. So let's say John runs a store. So he has a store. And let's say yesterday he counted 127 people. So yesterday, John counted, let's say 127 people who walked by his store. Okay. And out of the 127, let's say 58. So out of the 127, 58 let's say they came into the store. Into the store. And out of the 58, only 25, let's say 25, only 25 bought something. Okay, so again, we have 127 people walked by his store. 58 out of the 127, 58 entered the store. And out of the 58, only 25 bought something, right? So you need to find the probability that so one, that a person who walks by the store will enter the store. Okay, two, a person who walks by the store let's say will buy something. And three, a person who who comes into the store will buy nothing. All right. Okay, guys, I'll give you a couple of minutes to think about this exercise. So we'll do probably one or two more exercises. And then I will give you another formula. As I said, there are two different formulas to compute the probability of an event. So I will give you another formula to compute the probability of an event. And then we'll have more exercises, and I guess probably we don't have time to start a new section, the next section. But in the next section, we'll see some probability rules, how to add and multiply probabilities. Okay, but that will be in this next section. I guess see here, guys, I can add one more question. So a person who entered the store would buy nothing. But before that, we can do a different question. So, so before that, so let's say here, a person who entered the store will buy something first. So here we'll buy something. And here in four, the person won't buy. A person who entered the store, who enters the store, will buy nothing. So remember the formula we need to use here, guys. That's the frequency of the event, right? So that's the frequency of the event occurrence, how many times the event occurred, right? Over, of course, the size of the sample. So I'm gonna probably discuss with you guys, with each of you, your grade in the test, the first test on Wednesday. Um, as I said, I graded the test. The test was not. I think it was good in general. And I will discuss your grade on with each of you on Wednesday. But I'm interested to know what are your impressions about the test? Do you think it was long? Was it okay? I guess we covered everything in the test. I mean, if you check your review sheets or your homeworks, you can see we had like very similar problems, either in the review sheet or in the homeworks. But of course, I'm not sure because it's just 1 hour 15, right? So again, it's very short. I mean, that's very short time, 1 hour 15. You know, but my impression, I think it was okay. Not too long, but yeah. All right. Okay, so let's do this. Does anyone need more time to think about this exercise? Okay, probably not. All right, so yeah, so for question number 1. So when you read the question, guys, first you need to know exactly what's the event. So you're gonna compute the probability of something, right? So probability of some event A. So you need to exactly to know what's the event A here, right? So like in the first question says, we'll find the probability that a person who walks by the store will enter the store. Okay, so the event A would be here, a person. So a person who walks by the store will enter the store. So the event would be to enter the store, right? That's the event here. We are looking for the probability that the person who walks by the store enter the store, right? Will enter the store. All right, so in one, the event A will be that, so a person enters the store. All right. Now, what's the size of the sample here? So we are interested in the people who walked by the store, right? So we are interested, so the sample here, so as you can see, we are interested in the people who walked by the store, right? So that's our sample. So the size of the sample, so how many people walked by the store? We know that we have 127, right?
Yes.
People who walk by the store. So then, so the size of the sample here, size of the sample is 127. Okay, because we know that there are 127 people who walk by the store. Walk by the store. Now, what's the frequency of the event A? So how many people, so frequency of A. So out of the 127, how many people entered the store? Well, 58, right? As you can see right here, 58 people came into the store. Okay, so the frequency of event A is 58. So this is equal to 58. This is the size of the sample, and so 58 people entered the store. Right, so then probability of the event A, of course, would be the 58, divided by the 127, by the frequency divided by the size of the sample, and 0.46. Okay. So 46, I think that would be 46%.
Yeah.
Okay. All right. Any questions so far, guys? So frequency over the size of the sample. How many people entered the store over how many people walked by the store? All right, so number two, a person who walks by the store will buy something. So the sample here would be, so we are interested in the people who walk by the store again, right? So that'll be our sample, the people who walk by the store. And the event is that a person will buy something, right? That's the event. The event is that a person would buy something, right? So in two, so again, so the event B, or let's call this event the event B. It's a different event. A person will buy something. Okay. And the size of the sample, again, here we're interested in the people who walk by the store. So we have 127 people who walk by the store. So the size of the sample again here is 127. Okay, that's the number of people who walk by the store. So frequency of this event B, of course. So how many people bought something? Well, we know, right? We know that there are 25 people who bought something. So the frequency of B would be 25. okay, because we know there are 25 people who bought something. So then the probability of this event B, that's the frequency over the size of the sample again. So that's 25 over 127, right? And I think that's 0.20. So
yeah,
be,
0.20.
Yeah, so that would be 20%. Okay. C, a person who entered the store will buy something. So we're here, be careful. We are interested in the people who entered the store, right? A person who entered the store, we are interested in the people who entered the store. Now, what's the event? Again, the event will be that a person will buy something, right? The event that a person would buy something. So this is C. So we have this event C, let's say. So C is that, so a person will buy something. Okay, so this is like in a problem in the question number 2, right? The event in the problem in the question number 2 was the same thing, right? The person will buy something. But now the difference with number 2 is that in the size of the sample. So here we are interested in the people who entered the store. So the size of the sample in this case, so how many people entered the store? That's 58, right? So the size of the sample here, it's 58. That's because, again, guys, as you can see here in the problem, it says a person who entered the store. Okay, so we are interested in the people who entered the store. We don't really care about the people who walked by the store. We are only interested in the people who entered the store. So that's our sample. And out of the 58 people who entered the store, we know there are 25 people who bought something, right? So, so the size of the sample is 58, and the frequency of this event C, the person bought something, that would be again 25. So here we are only interested in people who entered the store. Right, and again, it's the frequency is 25 because we have, again, 25 people who bought something. So then the probability of this event C, that will be the frequency, 25 people who bought something, over the size of the sample. That's the number of people who entered the store. And we know there are 58 people who entered the store. Okay, so that will be 25 over 58, which is, I think it's 0.43. And that will be 43%. So as you can see, guys, so you need to be careful. So when you try to find like the size of the sample, you need to make sure that you know exactly what you are interested in, right? So for example, like in this event B, in question number 2, where we're interested in the people who walked by the store. Here in this question number 3, we were interested in the people who entered the store. We don't really care about the people who walked by the store, just people who entered the store, right? So we have 25 people who bought something out of the 58 who entered the store.
I have a question, Professor.
Yes, yeah, please.
So why didn't we subtract the 25 out of the 58? Or why did you choose to divide?
Here we are interested. So the event here, because probably I changed the question. You see here, number 3, we said a person who entered the store will buy something. So we know there are 25 people. Where is it? Only 25 bought something, right?
Yeah.
So we know there are 25 people who bought something. I guess you are talking about number 4 because I changed the the question number 3. In number 4, you see here in number 4, where we are interested in the people who enter the store and who will buy nothing. So then I'm going to subtract, and we're going to see how many people bought nothing, right? Out of the 58.
Okay.
Yeah.
Okay.
I guess you were talking about number 4. Yeah. Because I changed the number 3, actually. You're right, actually. Yeah. So yeah, in number 4, as you said, so the event is that a person will buy nothing. Sorry, nothing, not something. Will buy nothing. So yeah, so what's the frequency of this event D? What's the number of people who bought nothing? Well, you know, there are, where is it? Out of the 58 who came into the store, only 25 bought something, right? So then, so how many people, come on, what's going on? Okay. Yeah, my pen is not working. Okay, now it's working. Sorry about that, guys.
It's okay.
Come on. Oops. Okay, here it's working. Okay, perfect. Sorry about it. Yeah. So yeah, I was saying the frequency of this event D out of the 58 who entered the store, right? So then there'll be 58 minus 25, right? So 58 people entered the store. Out of the 58, 25 bought something. So then the number of people who bought nothing, that'll be 58 minus 25, right? And so that'll be equal, of course, to 33. Thank you. Okay. And again, the size of the sample, we are interested again in the people who entered the store. Size of the sample, that's again 58, right? Because again, in the question, as you can see, number 4 here. So a person who entered the store. So we are interested in the people or the persons who entered the store, right? So we know there are 58 people who entered the store. So that's why the size of the sample here, it's 58. So yeah, so then, so the probability of this event D would be the frequency of the event D, which is 33, over the size of the sample, which is 58, right? And that will be equal to, let me see my notes. It's 0.57. I mean, yeah, so yeah, 57%. Okay. So as you can see, guys, again, I'm gonna just make a remark and then we're gonna do one more exercise. Just a remark here. So this event D, I mean, if you compare the event D to the event C, so in the event C, a person will buy something, right? So the event C, a person will buy something, right? Out of the 58, the event C would be that a person would buy something. Here, D is that a person would buy nothing. And of course, a person will either buy something or won't buy something, right? Or will buy nothing, right? So this event D will be like the complement of the event C. And as you can see, 43% plus 57%, that's 100%. And that's equal to 1. Okay, so again, the person will either buy something or buy nothing, right? So either C or D. So then either C or the complement of C. So the event D, this is the complement of the event C. So the D, just a remark here. Oops. So D, this is a person will buy nothing, So this is actually complement of C, where a person will buy something. And again, a person will buy nothing, either will buy nothing, something, or will buy nothing, right? So this D is just the complement of C. So that's why probability of D plus probability of C, 43% plus the 57%, sorry, plus the 57%, that's the probability of D, plus the 43%, that's the probability of C, that's the 100%, that's equal to 1. Okay. All right, guys, one more exercise. How much time do we have first? Okay, cool. At least we're gonna try to have one more exercise. So exercise number 2. So let's say we have a survey of crimes, so of when crimes are committed in the Bronx. Okay. So in the first time interval, so here's time interval. And here you have like the number of crimes. Okay, so in the first time interval, that's from 6 a.m. to noon, 12 p.m. We have 290 crimes. From noon to 6 p.m., we have 135 crimes. From 6 p.m. to midnight, we have 319 crimes. And from midnight to 6 a.m., we have like 222 crimes. All right, so you need to find the following probabilities. So find that a crime, the probability that a crime so find the probability that a crime is committed during 1, 2, 3, 4. So let's say 1. This is from 6 a.m. to 12 p.m. and then from 6 p.m. to 12 a.m. to midnight, and then from noon to 6 p.m. And finally, is not, so find the probability that the crime is not committed from 6 a.m. to 12 p.m. Okay, so yeah, so let's say you have a couple of minutes, guys. I mean, time really goes fast. We have like just 10 minutes. Yeah, so let's say you have like 5 minutes to think about this exercise. So I guess I won't have time to present the second formula to how to compute the probability, right? So I will probably discuss this next time, and then I can start a new section, next section. So just be careful here, guys, about the size of the sample, right? All right, guys. So because we have like only 5 minutes, so yeah, let me go over this exercise, and then I guess next time, well, I guess probably I will start a new section. All right. So for number 1, so what's the event here? Find the probability that the crime is committed during from 6 a.m. to 12 p.m., right? So the event here, or the event A, so event A is that a crime is committed from 6 a.m. to 12 p.m., right? That's the event A. The crime is, so as you can see, when you read the question, it says the probability that the crime is committed during, like for one, it's from 6 a.m. to 12 p.m., right? So the crime is committed from 6 a.m. to 12 p.m. Now, what's the frequency of this event A? So how many crimes are committed between from 6 a.m. to 12 p.m.? So frequency of A. So yeah, the number of crimes committed between 6 a.m. to 12 p.m. is exactly this number right here. It's the 290, right? So that's the frequency of our event A. So again, that's the number of crimes committed between 6 a.m. and 12 p.m. So it's 290. Now the question is, what's the size of the sample? Any idea, guys? What's the size of the sample?
Is it 6?
Nope.
No.
So so we are talking about crimes here, right? The size of the sample, that will be the total number, that will be like the total number of crimes, right? Because we are talking about crimes. How many crimes in total do we have here? That's our sample. So, I mean,
okay.
You see, yeah. So, I mean, the 290, the 6, this is just the time. I mean, when I say like 6 a.m., 12 p.m., etc., this is just the time when the crime is committed, right? So it's not the size of the sample. We are interested in the crimes in the Bronx, committed in the Bronx, right? So what's the total number of crimes committed in the Bronx?
4, 1, 2, 3, 7.
Well, yeah. So you see the size here of the sample would be the 290. That's the number of crimes committed between 6 a.m. and 12 p.m. plus the 135. That's like the number of crimes between 12 p.m. and 6 p.m. plus the number of crimes between 6 p.m. and 12 a.m. And finally, the number of crimes between 12 a.m. and 6 a.m., right? So the size of the sample, that's the total number of crimes committed in the Bronx in one day, okay?
Yeah.
So that's...
It's gonna be 966.
Yes, 966, absolutely. So the size of the sample, this is the total number of crimes, total number of crimes committed in the Bronx. One more thing, guys, it cannot be 6 because it's the frequency, it's 290, right? And when you divide here by the size of the sample, so if you say, for example, 6, 290 over 6, that's, for example, I don't know, it's like, it's almost 50. But, you know, probability should be a number between 0 and 1. So it cannot be 6. That's impossible. So this number here in the denominator, this is supposed to be larger than 290. It cannot be less than 290. It has to be larger. Yeah, it has to be larger than 290. Because this answer here, it must be a number between 0 and 1, right? That's the definition of probability, right? That's our definition of probability. So yeah, so yeah, so the total number of crimes committed in the Bronx in a day, that would be the 290 plus the 135 plus the 319 plus the 222, and as Jinabu said, that would be 966. That's the size of the sample. That's the total number of crimes committed in the Bronx during a day. So yeah, so then the probability of the event A would be this frequency 290 over 966, and that would be 0.3. If I'm not mistaken. I think this is 0.30, and that would be 30%. So as you can see, this is a number between 0 and 1. Okay, and what we are saying, guys, here is that there is like 30% chance there's 30% chance that a crime is committed in the Bronx from 6 a.m. to 12 p.m. Right? There's 30% chance, 30% chance that a crime is committed in the Bronx between 6 a.m. and 12 p.m. Right. For number 2, okay. Okay, we don't have time. All right, guys. You know what? I will finish this on Wednesday, and as I said, I will give you a grade, your test grades, and then we'll start the new section. All right. Thank you for listening, guys, and I will see you on Wednesday. Take care, everyone.
Take care. Thank you. Bye, Professor.
Bye. Thank you.
Professor,
Thank you. Bye.
Yes.
Have you graded the homework yet?
Yeah, I did. I will give you the grade, the homework and the test grades on Wednesday.
Okay, thank you.
See you on Wednesday.